and say hello to our online students. And today we're on topic 6.5 on page 377. And at the bottom of the page, I've been working some problems from 6.4 to help people understand it before class. So if you sent me an email asking me to share this tablet with you, then you can scroll down to the end of topic 6.5 and see where I've worked out some problems from exercise 6.4 to help you make sense out of it. And we even went to the internet before class and used that that trinomial calculator thing to find some places where the computer helps you do it, so you don't have to do so much trial and error stuff. But I like that trial and error stuff. So for those who want to do it that way, let's just work on question 2 on page 377. Okay, look what question 2 says. Given 3 consecutive positive even integers. Did you catch that? Consecutive positive even integers. So, for attendance today, instead of that slip of paper, there's a card on your on the table. Put your name on the card and then put down some prayer requests. So this summer, while all of you are away doing whatever you're doing, I can pray for you and have fond memories of the time we spent in math class. So it helps my summer go better when I'm away from math all that time. And it gives me a reason to think about you and pray for you. Instead of just saying, I wonder what they're doing, and looking at my class roster and praying for you, I'll have a card with some prayer requests that you've written on there. Thank you very much. And the people online, you can send me some prayer requests for the summer through the email, just tombo9@juno.com, and say, here are my prayer requests for the summer, and I'll copy them to a card and pray for you too. Because after next Friday, we won't see each other again. Oh, yes, we will. Some of you are going to come back on Monday so you can correct your math test. But some of you will just say, no, I'll take whatever score I have on Friday and I'll just leave. Question 2, do you see what I did? I wrote down what they're wanting me to find. 3 consecutive positive even integers. So I said, okay, let's come up with 3 of them. Here's 2, 4, 6. You follow me? Here's 4, 6, 8. Here's 6, 8, 10. Okay, someone give me 3 more consecutive positive even integers. Nobody wants to give me any.
12, 14, 16.
12, 14, 16. You understand? Now, watch what it says next. The product of the smallest and the largest. That would be 12 and 16, right? I better get my calculator out here. We'll just take the one you chose, see if it works. The product of 12, what's it say? The product of the smallest, where did it go? The product of the smallest integer and the largest will be less than what? The square of the middle one will be less than 14 squared. What's 12 times 16? 12 times 16 equals 192. Is that less than 14 times 14. 196. Sure enough. You follow what we're doing? Say, well, does that work for all of them? Two times 6, 12. Is that less than 4 times 4, 16? Yeah. So I just start listing a bunch of them and then just go what? Dot, dot, dot to say there they are. Oh, but they want me using letters. And they said the product of the smallest, say 2n. So they're calling the smallest one 2n. See, I called the smallest one n. If the smallest one is n, let me change to green here. If the smallest one is n, then 2, the next one is n plus 2, and the next one is n plus 4. You follow that? To go from 2 to 4 is 2 plus 2. From 2 to 6 is 2 plus 4. 4 to 6 is 4 plus 2. 4 to 8 is 4 plus 4. You follow that? So it's n and n plus 2 and n plus 4, which says n times n plus 4 is less than n plus 2 squared. Or, since they said, let's change to blue, since they told us to use 2n, then this would be 2n, what? Plus 2, and this would be 2n plus 4. Then that would be 2n times 2n plus 4, the first and the last, is less than the middle one, 2n plus 2 squared. So that's probably what they're going to show in the answer book. Okay? Because they told you they wanted you to use 2n for the first one. You go, why? I don't know. They just did. Problem 3. The tens digit of a 2-digit number. You go, that's one of ours. I know. But since there's not one like this for the even ones, and I like working these kind, I'm going to work one of your homework problems for you. The tens digit of a 2-digit number is 3 more than the units digit. So I just made some up. The tens digit, if it's 7, the units digit is 4, because the tens digit is the units digit plus 3. Agreed? Isn't that what they said? And this is the tens digit, and this is the units digit. So the tens digit is 3 more than the units digit. So I could have 74, I could have 52, I could have 85. Can someone give me another one? You don't want to give me another one.
96.
What?
96.
96. Okay. Because the tens digit is 3 more than the units digit. Now, is that all they're telling us? Write an equation. If the number itself, that's 96, is 26 times the units digit, does 96 equal 26 times 6? No, so 96 is not our number. Is 85 our number? Wait a minute. It says 85 is 26 times? 26 times the units digit 5? No, so 85 is not our number. Well, we could spend a lot of time just trying numbers to see if they work, but instead we can say the units digit plus 3 is the tens digit, and this is the units digit, so 10 times the units digit plus 3, because the tens digit, ones place, tens place, right, is worth 10, plus the units digit equals 26 times the units digit. Now, let's go over here and just work this. 10, change it to blue. 10 times, no, it didn't change for me. There. 10 times u and 10 times 3. So we have 10u plus 30 plus u equals 26 times u. So 10u plus 1u would be 11u plus 30 equals 26 times the units digit. So minus 11u minus 11u, and end up with 30 equals 15u. Divide by 15, divide by 15, and 2 equals u. So the one that works is where the units digit's 2 and the tens digit is 5. Let's check that out. 52, does that equal 26 times the units digit? And sure enough, you say, we probably could have found that answer by just fishing around instead of doing all this complicated algebra. And I want you to realize that you can almost always find answers by fishing around and trial and error if you don't want to mess with the algebra involved. Number 4. The square of a number. So there's the square of a number, x squared. The square of a number x decreased by, that would be minus, decreased by twice the number is, that would be equals, 10 more than the number. 10 more than the number plus 10. Everybody see where I get for number 4? Do you see where I get all these letters from all those ugly words? Because I look at those words and I'm going, those words are ugly. But this is beautiful. So maybe that's why I like story problems so much. I enjoy translating from words into mathematical symbols. And hopefully, even if you don't like it, you can learn to do it. Write an equation that represents this statement. I just did, right there. You go, I wonder what that would be. Well, let's see. I go minus x, and I have x squared minus 3x equals 10. And I go minus 10, and I go x squared minus 3x minus 10 equals 0. So what would that be? X and x. How do I get negative 10? by multiplying. I multiplied two things to get negative 10, and I add those two things to get negative 3. Negative 5 and 2. So it's x minus 5 and x plus 2. And if it equals 0, then what would 0 this out? 5. What would 0 this out? Negative 2. So I have two possible numbers that would work for that, 5 and negative 2. You say, they didn't ask you to solve it. I know, but it's just fun to solve them. But for problems 5 through 14, they want you to solve those. It says write each statement as an equation and then solve it. So for 1 through 4, you just have to write an equation. For 5 through 14, you have to write the equation and solve it. So let's write the equation for number 6. 11 more than twice a number. I'm going to go back to red. Now, does that say 11 more than twice a number, or does that say twice a number plus 11? Does it matter which way I say it? Does it mean the same thing either way? I know it doesn't look the same, but does 11 plus 2n say the same thing as 2n plus 11? So what's your preferred way to say it? A or B? When you're looking at question 6, 11 more than twice a number.
B.
B? I have one vote for B. Anybody else want to vote for one of them? We have one vote for A. Anybody else want to vote?
I said B.
You said B? Oh, 2 votes for B, no votes for A. Anybody else want to vote? So the rest of you don't care. 2 people like B, and I wrote A. Go figure. My wife says, yes, Tom, that figures. If my wife were here, she would be taking notes and smiling, and when we get in the car to leave to go home, she would say, I told you, Tom, you're just weird. You don't think like other people. I'm going, okay. So I don't think like other people, I'm weird. I've accepted that fact. I know who I am. But you understand, if you don't see it the way I write it, there's another way to look at it. The idea is that you're translating from English into math. That's what, just say, I'm going to translate what number 6 says into math. So we're now going to change this. I'm going to mark this out. Well, if I can get the tablet to change, and say, no, we're going to say 2n plus 11. Then what's the next word in the statement? Is. How do you translate is? Equals. Is what? 19. It's too bad they didn't write it out. N-I-N-E-T-E-E-N. And then you'd have to put the symbol 19, but they didn't. Find the number. If 2n plus 11 is 19, now when they say find the number, what that really means is simplify. So I go minus 11, and I get 2n equals what? 8. Divide by 2, and n equals 4. And I just found the solution. Find the number. The number is 4. Everybody follow that? Number 8. If 6 is added to 7 times a number, so what did we do? Does everyone see where if 6 is added to 7 times a number, that's what we just said here? 7 times a number plus 6? That's your preferred way of saying it, right? The result is, that's equals 69. Find the number. As soon as they say find the number, I go simplify. Minus 6, 7n equals 63. Divide by 7, divide by 7. N equals 9. There you go. I just found the number. The number's 9. Does everyone understand what I'm doing when I simplify this? Am I doing something when I simplify that doesn't make sense to somebody? If I'm doing something, they say, what are you doing? Ask and I'll explain it to you. But the idea is, if we walk through these often enough, if you understand what's going on, then it eventually starts to stick in your mind. So that's why we just keep working these things. And if you get hung up on something, or the people online, send me an email and say, on problem number 8, I don't understand what you did when you divided by 7. Oh, well, that said 7 times a number. How do I undo multiplication? By division. So I divide both sides by 7, and I get n equals 9. How do I undo addition? By subtraction. How do I undo subtraction? By doing addition. You follow what's going on here? I'm simplifying. That's the key word. I'm simplifying. I'm taking something that's rather complicated and I'm simplifying it till finally it's down to where it's obvious. The number is 9. Number 10. 5 times a certain number. There's 5 times a certain number. That's equals 9 less than twice the number. 9 less than twice the number. Everybody follow how we got these letters from, how we got this math from this English sentence? What's the number? That's another way of saying find it. So I go simplify, and I go minus 2n, and that means I have 3n equals negative 9. Divide by 3, divide by 3, and n equals negative 3. And there's my solution. I just found the number, negative 3. And when you're working these, when you're finished, this is why you want to show your work. When you're finished, you check the answer. You say, the answer doesn't say negative 3. Then you say, what did I do wrong? And you can look at your work. You can go back and look at your work to see what you did wrong. Number 12. If 5 is subtracted from, you got that? I just start reading, and as soon as I see some words I can translate, I translate it. If 5 is subtracted from, so I put minus 5. Maybe I should come down here and do it in red. If 5 is subtracted from minus 5, if 5 is subtracted from half the square of a number, 1/2 of a number squared, the result is equals 1 less minus 1 than the number itself. Everybody see where I get that? And so now I just simplify that. And what's the first thing you're going to do? I mean, when you look at that and say, that's really complicated, I want to simplify it. What's the first thing that you see that bothers you to make it look so complicated? The 1/2? So, multiply everything times 2. Times 2, times 2, times 2, times 2. Everybody follow that? So now what do I end up with? 2 times 1/2 is 1. I'm going to go back to black here. So now I have x squared minus 10 equals 2x minus 2. Everybody see where I get that? By multiplying everything by 2? It's like you take this whole thing times 2 and this whole thing times 2. Okay? So now it's going to be easy to simplify, isn't it? No, I don't think so. I go minus 2x, minus 2x. You go, what do I take the 2x from? There's no x's in there, so then you just leave it. So you have x squared minus 2x minus 10 equals negative 2. But I want it to equal 0, so I add 2 here, and I end up with x squared minus 2x minus 8 equals 0. Then I take my 2 parentheses, I factor, or I go to the internet and use one of those programs to factor, and I get x and x. And then what can I multiply that will equal negative 8? And if I add them, they will equal negative 2. See what I'm looking for? How could I get negative 8? Multiplying. Negative 1 and 8. 1 and negative 8. Let's just keep listing them here. What else? 2 and negative 4. Negative 2 and 4. And which of these things added would give me negative 2? Which one would it be? 2 and negative 4. Everybody see that? What's 2 plus negative 4? I multiply them to get the last term, and I add them to get the middle term, the middle coefficient. So that means in my parentheses, I go x plus 2 and x minus 4. So what would the solution be? What makes this equal 0? Negative 2. What makes this equal 0? 4. So my solution is negative 2 and 4. There you go. Number 14. First thing I do is translate from words into math. 1/5, go back to red here, 1/5 the square, it doesn't say times. Well, here we are again. It's understood. If I say 1/5 of the square of a certain number, or 1/5 the square of a certain number, of means times, so 1/5 times the square of a certain number plus 2 times the number is 15. Do you see where I get my equation from those words? So now let's simplify. Let's take the whole thing, both sides, times 5 to get rid of that fraction. And we get x squared plus 10x equals 75. So x squared plus 10x minus 75 equals 0. Now I take this and say, what do I multiply to get negative 75, that when I add it, when I add those two numbers, I'm going to get 10. Well, 75, that could be 25 and 3. And see, since it's negative, so that could be 25 and negative 3. But see, adding that, I'm going to get 22. So I need numbers that are closer together. So let's try something other than 25. Like what? 5 times what? 5 and 25? Does that work? Can we find anything else? No, not 5 and 25. What would that be? 5 times what? 1 5 is 5. 5 times 15. And say, but if one's positive and one's negative, if I make that negative 15, then added, that's going to give me negative 10, and I want positive 10, so I just put down here negative 5 and positive 15. And that gives me positive 10. So there's my combination that's going to give me negative 75 when I multiply and positive 10 when I add. So what happens? What does this equal? X minus 5 and x plus 15 equals 0. So the solutions are 5 and negative 15. Everybody follow that? Number 16. What does number 16 say? The external tank and the booster of the space shuttle weigh 2.9 million pounds. So I put down the external tank plus the booster, and would be add, equals 2.9 million pounds. Why did I use ET and B? Because if I have letters that go with the words, it helps it make sense in my head. What's it say next? The boosters weigh 0.34 million pounds more than the external tank. So do the boosters equal the external tank in weight? The booster weighs more, so to make it equal, I have to add 0.34 million pounds to the external tank. You follow that? I write down the booster equals the external tank. No, it doesn't. The booster weighs more, so if it weighs more, then that means I have to add something to the external tank to make them equal. Follow the rationale? So now watch what happens. Let's change this to blue. The booster equals all of this. Agreed? So up here, in place of B, I substitute all of this. So now I have a new equation that says the external tank plus the external tank plus 0.34 equals this number I had to start with. So now I have 2 ETs plus 0.34 equals 2.9. Subtract 0.34, subtract 0.34, and I end up with 2 ETs equals 2.4. 0.56. Divide by 2, divide by 2, and the external tanks weigh 1.28 million pounds. Is that what they wanted to know for number 16? Find the weight of the tank and the booster. So the tank weighs 1.2 million, and if the booster is the tank plus 0.34, then the booster weighs 1.28 plus 0.34. 1.62. And there are my two answers. Here and here. Everybody follow that? Number 18. Mary is 12 years old and her brother Joe is 2. So, Mary is 12, the brother is 2. Now look what it says next for number 18. In how many years? There's the question. In how many years? So I go add years to Mary's, add the same years to the brothers, and what do you have? In Y years, you have 12 plus Y. In Y years, you have 2 plus Y. Well, what else are they saying? In how many years will Mary be twice as old as Joey? So this is Mary will equal 2 times her brother's age. So I end up with 12 plus Y equals 2 times 2 plus Y. Let's go back to black and solve this. 12 plus Y equals 4 plus 2Y. Minus 4, minus 4, minus Y, and 8 equals 2Y minus 1Y is Y. So Y is 8. So what's the answer? In how many years? 8 years. In 8 years. You go, what? Well, check it out. In 8 years, Mary is going to be 20. In 8 years, he's going to be 10. Well, look at that. Sure enough, Mary's twice as old as her brother in 8 years. Wasn't that fun? Number 20. You're not having as much fun with this as I am? Well, let's keep going, see if we can have some fun here. Number 20. In baseball, the slugging average of a player is obtained by dividing. Okay, here's how you find his slugging average. You divide his total bases divided by his number of times at bat. And Jose somebody had 2 home runs, 1 triple, 2 doubles, and 9 singles. So his slugging average is 1.2. So they said his slugging average is 1.2. Where did I get 24? His total bases. Total bases, not at bats, total bases. 2 home runs, a home run is 4 bases, so that's 8. A triple, that's 3 bases. 1 of those, 2 doubles, each double's 2, so that's 4. 9 singles, and that adds up to 24. So now I have 1.2 equals 24 divided by the total at-bats. Does it say how many at-bats he had? Oh, that's what I'm supposed to figure out. I've got 1.2 equals 24 divided by his total at-bats. Well, then that would be 1.2 times his total at bats equals 24. And his total at bats would be 24 divided by 1.2, which is 20. So what's his slugging average? No. What's his total at bats? 20. Number 22. A loan company charges $588 for a 2-year loan of $1,400. What's the simple interest rate the loan company is charging? Do they tell you anything about interest here? If it's $588 for 2 years, what is it for 1 year? $294. So interest equals principal times rate times time. He didn't tell you that, so you need to know that. So write that down so you'll have that information. So for $1,400 at $294, 294 equals 14 times the rate. R is the rate, and the time is 1 year. So it comes out to be 0.21 or 21%. Wow, they're charging him a lot of interest. If the time was 2 years, then you use 588, and it comes out to still be 21%. It's just a matter of how you want to look at the problem. Number 24. The Greens need to rent a station wagon to move some furniture. A station wagon? You need a truck to move furniture, people. If the round trip distance is 50 miles, so they just told me a round trip is 50 miles. So I write that down. Should they use a $50 flat rate? Should they pay $50? Or should they pay $40 a day plus 22 cents times 50 miles? Because that's how many miles they're going to be driving. Except they couldn't get everything in the station wagon or in the little van they rented, so they had to make 2 trips, so that even makes the price higher. But if they got everything in 1 trip, then 22 times 50 is $11. 11 plus 40 is 51. A flat rate is 50, so you better take the flat rate. Then if you have to make an extra trip, you're not paying for the extra miles. Generally, the flat rate's the better way to go. Number 26. Use the formula in problem 25. What's the formula in problem 25? There it is. I just copy the formula down. To find the rate of interest $1,000 will earn to grow to $1,400. So the amount I want is $1,400. The principal is $1,000, and they want me to find the rate. So I divide 14 by 1,000, and I get 1.44 equals 1 plus r squared. And 1.44 is 1.2 squared. So if 1.2 squared is 1 plus r squared, then 1.2 equals 1 plus r. Subtract 1 and you get 0.2 equals r, and 0.2 is 20%. So if your money's going to grow to $1,440 from 1,000, you're going to need to make 20% interest. I don't think anybody's paying that. Number 28, the reaction distance. A car travels while the driver is moving his or her foot. Do you understand this problem is very important for you? Driving a car. By the time you get your foot off of the gas pedal, onto the brake, that's called reaction time. If you see the car's taillights come on in front of you, if you're too close to them, your car's moving fast enough, before you get your foot to the brake, you run into them. Why do people follow on somebody's bumper? Well, I wasn't expecting them to hit their brakes. Well, you weren't expecting them not to either. So anyway, the formula is R. How come I didn't write it down here? The formula is R equals 1.5 times T times V. So I put R equals why did I say 1.2? $1.5. This is 1.5. I don't know why I said 1.2. $28. A car going 30 miles per hour, go back to red. A car going 30 miles per hour goes this far. So what's 30 times 1.5? Not 36, but what, 45? So what's 22.5 divided by 45? 22.5, 22, come on, 22.5 divided by 45 equals 0.5. So it's going to take you half a second, 1001. So half a second to get it over there. Number 29. Use the formula D equals 1.5 TV plus 0.06 V squared. So you just plug in the numbers for number 30 that they give you and use the quadratic formula calculator and solver from the internet. Once you've got it set it up where it's equal to 0, and this is A, this is B. Don't forget the sign and the decimal point. And this is C. And plug those into the quadratic formula calculator on Google, and it'll do the calculation for you. Because you don't have to do the calculations for these. You just the problem is learning to set them up. Number 32. What's 32 say? If cars' headlights will illuminate objects up to 200 feet away, 200 feet, and you're driving 50 miles an hour, when you see a dog on the road, what must be your reaction time if you're going to stop before you hit the dog? Reaction time, reaction distance. Reaction time, that would be T. So reaction distance is 200 feet equals 1.5 T times velocity, 50 miles per hour, plus 0.06 times velocity squared, 50 squared. So you get 200 equals 75 T plus 150. All of this becomes 150. So 50 is 75 T. So 50 divided by 75 is 0.6666 is T. The answer key says 2/3. If you divide 2 by 3, you get 0.6666. So what's the time it's going to take? 2/3 of a second. 34. Pedro reacts very quickly. His reaction time is 0.4. So I put reaction time is 0.4. He's driving on a highway. He tried to stop. His car traveled 120 feet. How fast was he going? So I need to find the velocity. So I plug in 120 equals 1.5 times t, the time, times v equals 0.06 v squared. And now I'm back to using the formula again, where 0.06 is A, plus 0.6 is B, and negative 120 is C. And plug it into the quadratic formula on the internet and you'll find the answer. Number 36. Wow. No. Stop when you get to 37. That's too bad, but we're just out of time. We'll do one more, problem 36. Stop when you get to 37. Let's do problem 36. A wallet contains $20 bills, $1 bills, and $5 bills. The total value is $80. How many $5 bills? How many $5 bills can he have? What's the most he can have in $5 bills? So I go, well, F will be my $5 bills, and 20 minus F will be my $1 bills. And a $5 bill is worth $5, so I take $5 times the number of $5 bills plus $1 times the number of $1 bills, and it has to be less than $80. 5F plus 20 minus F is 4F plus 20 is less than 80. 4F has to be less than 60, so F has to be less than 15. So less than 15, I can't have $14.50 bills. So 14 is how many $5 bills I can have. What's 14 times 5? 20? 70? I can have $70 in $5 bills, and then that means I have $10. Then that means I have 10 ones. Does that take care of $70? Oh, less than 80. So 9 ones. I have 20 bills. What happened? Oh, 4. What did I do wrong?
It's less than or equal to 80. It can be equal to it.
It could be equal to it?
Yeah.
Less than or equal to? So if I have 15, then times 5 is 75, and that's 5 ones. Okay. So the answer is not 14, but it's 15. Because I forgot to put the less than or equal to in there. Well, that'll mess you up in a hurry. Thank you for checking that out. Okay, stop when you get to 37. I'm sorry we couldn't work more problems. Be sure and put your name on one of those little cards and write down your prayer request for the summer. If you don't give me a bunch of prayer requests, I'll still pray for you. I'll just make up some prayer requests. And I'll come and pick the cards up, but you can put your homework up here, or if you want to, thank you. I'll take the cards. Thank you very much. If you have some questions, stick around and I'll help you work on them.
Thank you.
Thank you. Have any questions?
Can you do number 65?
On this topic?
6.4.
On 6.4, number 65. 6.4, number 65. Yes, you have a question?
Yes. This is my 5.8 that I did.
Uh-huh.
But I realized I was stupid and I did my notes for this
Oh,
chapter
yeah?
on it. So can you just like mark that I turned it in?
I see it. Just write me a note and say I showed you 5.8 and put your name on it, and that'll take care of it. 65. The cost? Yes.
I just wanted to tell you I will not be here on Wednesday next
Okay.
week because I'll be at track nationals.
All right. Well, have a good time.
Thank you.
Win a prize.
I will do my best.
All right. The cost is 0.1 x squared plus x plus $50, right?
Mm.
To serve X customers. Okay. How many customers can be served if the cost is 250? So they're saying 0.1 times x squared plus x plus 50 has to equal $250, right? So I go minus 250, minus 250, and I get 0.1 x squared plus x, 1 plus 1x, minus 200 equals 0. Agreed?
Yeah.
Now, since I don't like decimal points, I just take the whole thing times 10. What's 10 times 0? 0. And now I have x squared plus 10x minus 2,000. See that?
Mm-hmm.
Now, what two numbers multiplied would give me a negative 2,000, and when I add them, I would get positive 10. 40 and 50. Oh, man.
Where did you get the 200 from?
They told us that in the formula. Or no, they told us 50, so I copied down the formula, but I had it equal to 250 because they said that's what it costs to serve this bunch of people.
250.
Yeah, see that 250? And then I subtracted 250 from both sides. So 50 minus 200 minus 250 ends up being minus 200. I better turn this off. The people online probably aren't interested in hearing all this stuff.